Okay, yesterday we discussed that protostructure has a suite which comprises of 4 components. The program that we have installed comes with 3 components. That is the protostructure environment, which you have as this one with the red icon on the desktop. Then it comes with protosteel and also protodetails. For our training, we are going to look at protostructure and protodetails. Now, when you install the program, it chooses its default project folder. Now, the default project folder of protostructure, as if it is a fresh installation, you'll get it in documents. When you go to documents, you'll find a folder called protodata 2021. If you have protostructure 2025, 2026, that folder will be protodata 2025 or 2026. So within that folder, all the projects that you're going to do, that is where they will be stored. So, but you can change the file location for your project, right? So when it comes to sharing projects between different machines or different computers, you will have to share a folder of a particular project. For example, in that folder, there are some sample projects that come by default as we install the program as examples of projects that can be done using protostructure from the company. So once you open one of them, for example, if I can open this project, it has a long list of files. So when you're sharing your work with someone, you are supposed to share the parent folder. For example, if I go back to, if I go one level back, so I'll be sharing the entire folder. It's not like you have worked with the Microsoft Word document, you're going to share only one file. So here you share all the files that come along with the project. Okay, having identified that, we can now open protostructure. You're going to open this one with a red icon. You double click on it. So if you have internet connected, however much we are using pirated software, as long as you are finished to crack it, it will still be like you'll be able to work with it fully. Okay. So like right now, I'm on Zoom, but I can still work with it. So after opening the program, this is protostructure 2021. It is only compatible with the protostructure 2021 and above. If you have protostructure 2018, the file that you have created using this program, you may not be able to open it in that other version. So it's like all these engineering programs, whenever you have created a project in a program of a lower version, you can only open that program in a higher version of the same program, right? Okay. So at this interface, We have two sections, a section where you can open an existing or create a new project, and another section where you can get the different, like the information from the company, what are the changes. If you don't know what or how to do something, there are always these videos which the company puts here for you to review, but they can be accessed online only. Now, I'll click on new project. I don't have any a project that I'm opening. I've not created any project. Okay, so I'll choose a new project. You click on new project and then you provide a project code. This project code, I'm going to have the file name as mock. Then if I want to put a space, it's better you use maybe a hyphen or anything, but you shouldn't use space bar to create a space. It will not even allow it. Okay, so if you want to separate them, you can use a dash training. That's the project code. So we have a long list of design templates or template codes. We are going to be using Eurocode UK. Then here we have templates or projects. We have not created any project yet. When you are starting just something fresh, you may need to start with a template. After you have created that project, the different settings that you have given it, then it can become your project template, which you can use on other projects to avoid configuring of settings all the time. So in your next project that you will do, you just come to projects and choose that previous project that you worked on. When you choose that project, then your current project will open with the settings of the previous project which you did. So at this moment, let's have template. And then we use the template code UK Eurocode. Then click OK. So at this interface, in AutoCAD, we have a construction grid. Like on C, I also have a construction grid. This construction grid, it has major and minor grids. Major grids spaced at 5 meters, and the minor grids are spaced at 1 meter. If you count the number of squares, there will be 5 until you reach to the major grid. But it's not a must that they should be at that interval, okay? So if in case you want to move with snaps of grid intersections, maybe in increments of maybe 2 meters or 3 meters, it's upon you. You can readjust this construction grid. Where we adjust it from, it is in the settings center. There's an icon at the top. This icon at the top, which you can also access in where's the, okay, let's have it. Let's click on this icon at the top. Settings, So under settings, we have ProtaStructure environment. When you expand ProtaStructure environment, just click on that arrow next to ProtaStructure environment. You'll find view and save, and then display settings. So under display settings, that is where you can configure all the parameters linked to that construction grid. The colors, if you click on grid, that's where you get the grid step. If you want to adjust it from 1 meter, maybe 2 meters. By default, this program opens with input units of a millimeter. It uses a millimeter input unit. So here, if you need 1 meter, you have to put 1,000. 2 meters, 2,000. So the major grids, if I put here 5, also 2, for example, the other side, I'll get increments of 2 meters to reach up to the major grids. So I'm not changing anything here, but it was vital for you to look at it if in case you need to make some changes. So just keep it default. And let's look at under unit and format. You click on unit and format. When you're starting to create any project in any software, it is good practice to look at the unit of measurement. So here, what we change is the length parameter. Okay, in case you want to change the length in meters or millimeter, the member dimension is in millimeter. Okay, so by default, we shall have a millimeter. We are not changing anything. You get your project from the architect when it is represented in millimeter. So just keep working with a millimeter, unless there are some architects which who prefer using feet and inches. So what is favorite? Actually, favorite, I also don't mind. Yeah. So indeed. Okay, so just that we have not changed anything. Now, how do you bring in your work? Yesterday, I said you can either start with preparing a general arrangement drawing in AutoCAD, or you may not, as long as you know your effective spans. Okay, so under building set out, okay, under modeling, you look at modeling. Modeling, we have an orthogonal axis generator. In modeling, click on orthogonal axis generator. So I have grid number 1, grid number 2, grid number 3, grid number 4, grid number 5, and then grid number 6. So this can be represented as A, B, C, and D. Now, when you have not created an AutoCAD file, I'm assuming this is your grid. These are your grid spaces which you have achieved. Okay, so you may use the orthogonal axis generator to create this construction grid at once. How you can use it? You click on the orthogonal axis generator. I'll click at it. Then just click anywhere on that construction grid. It can be here. If I click here, I'll get that dialog box. So wherever you have clicked, you get a reference point. That reference point will have coordinates based on the position of insertion. Now, we have direction 1 axis and direction 2 axis. If this is my construction grid, always direction 1 axis, they are going to be the axes which are parallel to the x-axis. And then direction 2 axis, they're going to be axes in this other direction. Therefore, when I'm entering distances for direction 1 axis, I'm going to be entering 9, 6, 6. For direction 2, I'll be entering 3, 2, 2, 4, 7. These are represented with alphabets. If I look at this, under direction 1 axis is an alphabet. If in case you had labeled these ones with numbers, then you are going to change this to be a number starting from number 1. Okay, so I'll keep it default. Then the spacing, axis spacing, since this is direction 1, actually let me have it written here, direction 1 and then direction 2. So direction 1, we have 9 and 6 2 times. So what you put here is going to be 9,000, that is 9 meters. You place a comma. You put 6,000, you place a comma, then 6,000, place a comma. It is okay. But then I have repeated 6,000 twice. You can do it like this, or you just type 6,000, you multiply it times 2. Then if there is another spacing, you add a comma, put that spacing. So I'll end at that. Then I'll go to direction 2. This is going to be (2,000 times 2, comma, then I have 3,000, is it 4,000, comma, then I have 7,000. Now for axis extension length, we're having 2,000. That axis extension length represents the distance. If this is my axis, if let's say this is the grid D, from the from this last grid up to where the axis extension is. This distance is 2000. So you can keep it default or you just put any figure that you want, but it shouldn't be too long. So for this, I can have it maybe 1500 and here 1500 to be a bit uniform. Now we have a step. What step means is that you're going to reach a time when you are just pressing the arrow keys on the keyboard to shift the position of one element. So here, this means that whenever I press, let's say the up button, the grid will move up by 1 millimeter. Okay? So we keep that the way it is. This grid, okay, for direction 1, there are these ones here. There are these ones. If I select this grid, for example, the upper one, and I press the arrow key on the keyboard, which like the arrow key which represents up, it will shift from this position by 1 millimeter. You get it? Yes. I'll click OK. And I'll have the grid spacings as that. So with this already created, the amount of time you have saved to create the grids in AutoCAD is already catered for here. So you can just begin placing the column positions where it should be. So that is if you are using an orthogonal axis generator to start your project. This applies for small projects, but for big projects, you will take a lot of time with this. Yes? Are we okay up to that step? Okay. So what we have just gone through is you have got all the centered dimensions for these grid spacings already. So I don't expect you to get hardships when you are trying to come up with a layout of your grids with this project. Okay. So if you have positioned your columns, let's say at this corner, at this corner, at this corner, the distance is already indicated there. If you cannot determine the distance from here, the AutoCAD file is there. You can measure and then get the exact distance you want. Okay, I'll delete all this. Delete all that you have created, and then let's get back to the actual project that we are handling. Yes. Yes. Yes, thank you for that question. Yesterday, I went through the AutoCAD and made isolations and created a DXF file. Okay. That is, there are two methods of starting a project in Protastructure. You can start without creating that DXF file. That is what I was discussing right now. Then, if you want to start with a DXF file, that is what we discussed yesterday. You have created the DXF file. Now you want to bring it into Protastructure. So I've decided to discuss both methods. You choose what you feel is convenient for you, right? Yeah. Yes? How do you edit the grids you have created? We are going to discuss that one in depth after you have brought in some other grids. So you first delete all that. We are still getting back to that point. You delete it. Then one other thing which I'm going to request you is, I know some of you might be working with some firms which are you already using these softwares, and the computers that you are using, they already some projects for Protastructure. I'll request you to first put on hold the projects which are already done. Let's first concentrate on what is here. Then when you go back home, review what has been done related to what we have discussed. If there is something missing, you come and tell me in our next meeting. But then you're referring to what is already there, and then also what I'm discussing, you get confused. Okay? Okay, so now let's start the actual project, the actual training project, right? In the files that I shared with you, there's already a DXF file, which is, it's called DXF file dash general arrangement drawing, GAD. Confirm that you all have that DXF file before I proceed. You check in the folder called class file. There is a DXF file. Okay. All right, let's proceed. Now, we start with building set out. Under building set out, we have external reference drawing. Click on external reference drawing. Under building set out, click on external reference drawing. I'm making a recording for this class, then later I will share with you the recording to review in your own free time. Okay, or you can write some notes where you think it is necessary for you to refer to. Now, under building set out, click on external reference drawing. Then you click on add, where there is DXF down there, you click on add. Click on add. Then you locate where that DXF file is. You must make sure that where it is not a zipped file. Because if it is a zipped file, you will not get it. You will not see it from this window. We all understand a zip file, what it is? Yes, make sure that where the DXF file is not a complex folder. Right? So select that file from where it is. This is what I created yesterday. So click on DXF file, GAD, select it, and then click on open. After clicking on open, you will see the file path. You can make it active. You notice that I'm creating this, I'm bringing in this DXF file at story 1. You see where we have stories, there is story 1, 3 plus 3.00 meters. It is the one which is bold. So when I'm bringing in this DXF file, it will go to that story. Make sure that, anyway, by default, when you're starting the project, it will be there. So when you click on active, then click OK. Do we all have that DXF file there? Now, you have linked it to your project, but this doesn't mean that you have used it. It is easy for you now to determine your column positions and where your grid lines are going to be using this DXF file. Now, you already have column positions. You're going to import them into this file. So go back to the same external reference drawing. When it is active, you click on import. Click on import. You have a layer for grids and a layer for column. You mark the layer for columns. Assign layer first. Okay. So let's first assign a layer to it where there is column. I'll mark, you click on, you see under layer, there are some arrows. So in line with column, which is grayed out, click on that arrow and give it a layer, structure column. Then click OK. The overall aim is to make it selected here, but you cannot select it before you give it a layer. Okay. So after that, you click on import. Click on import. And close. You click OK. After you've clicked OK, when you are in the external reference drawing, in the dialog box for import, you need first mark. Select the layer for that column. After you have imported, you close. Okay. Now we expect a difference in, like there should be some unique difference between the grids which are running horizontally and the grids which are running vertically. But now when I look at this, all these grids, they all have the same color. They all have the same color. This means that your DXF file is still seen. Why we brought in that DXF file is to link it into this project to help us get the exact column locations. If they are there in the DXF file, we import them. But then its use is already finished. So we do not need it to be displayed there. So under external reference drawing, you can decide to make it deactivate where there is active and mark it. Or still you can just click on remove. It's no longer needed. For now, you just mark active, like make it inactive, right? Just make it stays in the project, but it is inactive. If you mark. Yeah, it shows in 3D, in the 3D window. Here it shows in plan, and then if you want to activate it in the 3D window as well, it will be shown in the 3D window. Yes, what we have right now, we can get the 3D. All right, so okay. Now you ask a question to do with how we edit the grids that are already there. Okay, so these grids, yes. The naming of the structure columns, do you also name them the same way as how? Yes. Now, the name which we gave in AutoCAD, it was for a layer, remember, structural column. It was for a layer where we were going to place those columns. You could have noticed that at the point of importing them using a DXF file, that layer which you activated first, that was the layer called structural column. So it comes right from AutoCAD, and then it is recognized in ProtaStructure. So the naming of these columns, which are now in ProtaStructure, is going to be different. Like, for example, you can see this one is 1C32, okay? Right now, once you have exited AutoCAD, you shouldn't think about layers again here. You get it? Because ProtaStructure, yes, it works with the layers, that is true, but there's default layers where all these structural elements are modeled. You get it? How did it identify it that this? I don't know, but that is how the programs were made. Because how it identified it, you created polylines, closed the rectangles. So the role of ProtaStructure is if you have an enclosed polyline, it will still give you, if you need it to be a beam, it will be a beam. If you need it to be a column, it will be a column. That's why if I had another layer called beams, because also beams you have closed loops, right? So if in case when I was importing here, and instead of choosing column, and I choose maybe structural beams, it was going to extrude beams instead of columns. You get it? So I don't know, but that is how it is. Yeah. Okay, now we need this one to be, I think let's give these vertical ones alphabets, right? This is A, B, continuous. Okay. So I'll double click on this grid. That is how you can edit the naming. Double click on the grid. Then from here, where there is label, you get where there is label, you write A. And then update for it to change. You double click on the next one, label, this is B. You update, it changes. So we are going to keep on seeing this update, okay, updating the elements. You can only update what you have created, right? So whenever you are making a change, we need to mark update. Now, you're not going to keep on double clicking on these grids one by one. You take a lot of time, okay? So you select them in their order without skipping any. So for example, we have stopped at B, click on the next one next to B, it's supposed to be C. Select it, hold Control, click on the next until they are all complete. As you hold Control, go on clicking on each in their order. After you have selected all in their order, you right click on one of them. It can be any, right? Just right click on one that has been selected and then choose properties. So we are there. You change the descriptions of these axes in their order from up to down. This is supposed to be C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, W, X, Y, Z. Yes. Yes. Yeah. They say continue. Z. You also stop at X. I also in at X. People up. Pass cross. Yes, that one. Now, you have mixed them up. But me, I have reached Z and I'm even still continuing. Okay. skip sequence. Okay. So this was supposed to be R. R. Yes. U. Oh, you are right. They are stopping at X. Yeah, A prime. Okay, just mix them up. A, first change them to characters which are not there completely. Or it could be AP, or then after you come back to the ones which are supposed to be there. Okay, they are supposed to end at X. Okay. Now, if you have made a mistake and maybe you find that you have mixed them up, you cannot, for example, if this was supposed to be J, but I've put D, if you right click and change it to J, it will not change. You need to first change it to a character which is not existing, maybe UU, then you update it, and then first change the other one which is already there, J, to something else, then you can come and update this other one. Not deleting, rename. You just continue with others. You need to first delete this, the other ones. Okay, so let's rename the horizontal ones, starting with 1 from the bottom. I'll select this, that. Then the properties, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we are there. Okay, now all these grids have been imported just at once. It's going to reach a scenario where you may need to add more grids which you do not have. Okay, so how you can create a grid is under modeling. You click at grid, modeling, click at grid, then you draw from one point to the other. When you're moving to be horizontal or vertical, you press Ctrl. Okay, so that is how you can draw an independent grid. When you click on grid, click from one point, hold Ctrl to make it straight as you move, then to another point. If you find that maybe this grid was supposed to be extending up, but it ends here, you right click on that grid and choose stretch axis. Stretch axis from this point, then to where it should be. Okay. If I need to move them together at once, if I need to extend axes together at once, I'll make a window selection like from bottom right to top left. Okay. I'll make a window selection like that. Make sure it's having a green background when you are selecting. I can select all the grids like that. Then you right click, stretch axis to a boundary. After you have selected them, you right click on one, then stretch axis to a boundary. Then you draw the bound where they should extend to. Maybe you want them to end up to here. From this point, you just need to draw a straight line. It may not be exactly where they end, but it can be, as long as you have drawn a straight line above, they should stretch up to that bound. Okay, I'll undo that. Now, in case you want to shift their position, you can select it and use the arrow keys. Okay, you can select it and then you right click, offset axis. Offset axis. Now, once you click on offset axis, you need to press F2. F2, you're activating dimension. You're offsetting it by, let's say, 1.5 meters. And then enter. If it is this one, I'll select it, right click, offset axis. I'm putting it now on the left. It's going to be a negative measurement. So F2, negative, let's say 3,000. Enter. It will create another one. Likewise, if you're moving up or down, you're moving up is going to be positive, down, negative. Yes, if you select the grid, you right click on it and offset axis. You want to move a particular distance, you press F2, activate. Right? Then you type the distance that you want, then press enter. Okay? Yeah, if it is negative x, you do negative. Positive x, you do positive. Now, I have deleted the extra grids that I have just created above, and I want to concentrate on these ones which are here. Is it okay? Once you choose offset axis, press F2 to activate the distance. Is that okay? Now, the beauty with using a DXF file, I have already started even modeling. I already have the columns there. Okay. So, but when you do not have a DXF file, you start with creating columns. And those columns, you're going to place them at intersections of grid lines. That's why you must have grids first. Now, if you're creating an independent column, you click on column under modeling. There is column. You click on column. Then you give it a size, B1 and B2. That is the section size, length and width. So if your column is going to be, let's say, 400 by 300, or let me have it as 600, 400 by 600, then you choose where to draw it. Let's say here, you must place them at axis intersections. I'm assuming that you already determined where the columns are going to be. So just choose an axis intersection and the column will be placed there. Or press escape. Yes. When you're creating the columns, okay, when you're starting the project, you start with creating columns. But for you to build those columns, you need to place them at axis intersections, which you already have now. Those grids are axis. So if you launch on the column tool, when you click on column, you need to provide a section size. You must have a section size no. B1 and B2 in the properties. So if you want a column of, let me use a rectangular column of, let's say, 300 by 600. And then I'll place it, let's say, here. So this column it has an eccentricity, which is 0. You should have noticed when you are trying to create it, there are these other values, A1 and A2. So these two values, they are linked to the eccentricity of placement. When I type for E1, let's say about 30, and I update, this column is going to move in the X direction, 30 mm. But you would want to shift these columns just with using your arrow keys, like incremental distances. So in the setting center, and in the product structure environment, where we have view and save. You see where you have view and save. If I need to add eccentricity of those elements using the arrow keys on the keyboard, there must be an incremental distance which you're going to be shifting. Okay, so by default, the member section eccentricity step is 25 here. So whenever I select a column and I press the arrow key on the keyboard to shift its position, it moves 25 millimeters. You get it? So if you need that to change, you can change it from here. Okay. I'm not changing anything here, but I'm showing you just in case you want to do something like that. Okay. Okay, let me first cancel this. You see this column? Okay, this particular column here. When I select it, when I click at it and I press the arrow key down, it shifts down. And if I press again, it shifts again. So by the fact that it is not, its center of gravity, it's not in the center of the column, okay? It is at a given distance from the axis. Okay, these two distances are not the same from the axis intersection. That is the member eccentricity. So whenever I was shifting the column like that, it moves a given step. So those incremental steps, that is the 25 millimeters. So which you can configure from here in the settings center. If you go back to product structure environment, view and save, the member eccentricity step is 25 millimeters. But I can put here 10 millimeters in that if I press my arrow keys on the keyboard, those columns will be moving 10 millimeters, 10 millimeters. You get it? Yeah. Scenarios where you will need to have eccentricity, we are going to see that after we have added beams. The direction of the eccentricity using the mouse, it will be determined automatically. Okay, it's like you have E1 and E2. Take E1 as horizontal distance. Then take E2 as a shift in the vertical distance. Yeah. So if you have added any column, you delete it. The column that you have just drawn there, you delete it. Let us leave the columns that we imported. Yeah. Okay. Now, let's focus on stories. We have a structure, which is a 5-storied structure. When you are starting the project, this is the only important structure. It assumes that you're already on first floor. You're already on first floor. That's why when you look at here, story 0, here it is this is the foundation. Then story 1, first floor level. That's why here it is 3 meters. But when we are constructing, let me have the cross section. Let me use this cross section. This file. Now, if you look at this cross section, this is the foundation at the base. So for proto structure, it assumes that you have this level, and the next level you are here. Okay? But ideally, in the normal construction, you're going to have this level. So we need to add this level. Why it is like that? We do not design for this level, which is at the ground floor. This level is already, it's already strong. You're going to add the core, it's ground bearing. Okay. So when we are designing slabs, we start with suspended floors. Now, let us create this floor here, because that is what is going to happen in normal practice. Okay. So I'll go back to proto structure, add more stories now. So in the building set out, access story operations. Under story operations, there's that drop down. For some computers, this command here may be compressed depending on the resolution of the computer. So you may have to go through some drop downs to access them. Yours. It shows stories and then the other one is inside. Yeah, that is the resolution effect. So in the story operations, let's have insert story. Insert story. Let us include, let's have 6. We can have many, and then after you've named them according to how you want, you can delete some which you don't need. So let's have 6 stories, and then click OK. This operation cannot be undone. Let's accept. You click yes. After adding the stories, now we need to clearly identify those stories, which is which. Story 1 is what? Okay. So still under story operations, we edit the story. Edit story. Now, in this window here, for story 0, you will not have it appear in this window here, okay? But we begin with this level. This is called the plinth beam level. From the foundation, you add the plinth walls, and then on the plinth walls, you have the plinth beam, okay? So in our configurations, this should be the plinth beam level. Okay, so you can take this as to be the ground level. Okay, like the way how this man named it here. Ground floor. Okay, ground floor. It will be that level. Then, but me, I'm calling it plinth beam because I have a plinth beam at this point. I have a plinth beam at this point. That plinth beam, the substructure is going to look like this. So it is this part here. You see where we have hardcore, there's a beam crossing here. So this is a plinth beam. That's why me, I'm calling it a plinth beam level, but they labeled it as ground floor. Okay. Then from the plinth beam level, now we shoot to first floor. I'll type first floor. Then this is going to be second floor. And this is going to be third floor. Okay. Yes, please. As don't give up. So we have ground floor, first to third floor, then a roof terrace. So I think there should be also, this should be the roof terrace, roof terrace floor. So this person named it roof terrace, but this is fourth floor. Okay, just take it as fourth floor. Because there is a terrace, then decided to name it. Let's have it as fourth floor. Then we end with a ring beam level, or roof level. I don't know. Ring beam. Just ring beam. That is the last level where we are going to do roofing. Okay. This other, if I look at the roof plan, I have the first floor, second floor, third floor, terrace, and then there are some parts inside which have a roof. So at this point, you have the ring beams. The water tanks. Those water tanks are going to be placed at that level. Yeah, where you have the ring beam level, that's where you shall have the water tank slabs. Get it? Yes. Yeah, it is, but I don't know. is catered for. I'll explain that. So we are all at the same page. So ring beam. Then after that, you see at this level, this is ground. So we should expect to be actually like how this man represented it here. We should be at 0. Okay. This here, you should be at 0. So you also have to reduce your levels to indicate that at this point you have 0. So how you achieve that, you need a negative distance within the ground, like you go in the foundation. So I'm going to have a negative distance of 1,500. So in the building section, it is not indicated. So, and the first story bottom level, I'm putting negative 1,500. But this 1,500 is not just put it just like that. You get this distance from the geotechnical investigation report. Okay? From the geotechnical investigation report. Before you do structural design, you must carry out geotechnical investigations. So in that report, you'll find as if okay, if this is the site, okay, if this is the site where the construction is going to be, maybe it is localized around here, okay, then some trial pits are going to be done in any given pattern, depending on how they could have done it. Maybe they are going to pick samples at this point, samples at this point, maybe other samples at this point. Okay, so here you have 2 trial pits in the site. So in this trial pit, you're going to have a surface exploration and then also a subsurface exploration. Increments of maybe from 0 when you are at the surface, you get results of the DCP. So you get results at a height of, let's say, 1 meter down below the ground, and then you get DCP results of at a height of 2 meters and maybe up to a height of 3 meters, right? So this is for one trial pit. You have DCP results at this point. So you do the same for this trial pit and also do the same for this trial pit. You have different results along as you go down into the ground. So you might find that at for this trial pit, when you are at 0, the bearing capacity of the soil is maybe 170. And then when you went at 1 meter, it became, let's say, 162. But then when you went at 2 meters, it became at 185 and maybe 190 when you're at 3 meters. So these bearing capacity results, you're going to get them for this trial pit, the next trial pit, and the other trial pit. So if I base that the bearing capacity or the foundation design is going to be based on dry pit 1 because it is the one which is having the least bearing capacity. Then that bearing capacity was got at a height of 1 meter. So therefore, that distance of 1 meter is what you're going to have in that input. Is that okay? Yeah. So I'll have 1.5 assume the value because I don't have a report. Then the foundation depth. Let's have a foundation depth of 400. This depth here, it is the depth of the footing actually. This is the depth of the footing. When you are doing design, you must have an input first, which you're going to test. So let's have 400. And then how we are going to reduce this to 0, you put a height of 1,500 here, and then the level becomes 0 here. The height that you have put here, reflect it here, the positive sense. Then this will be 0. Then the other thing is, what is the headroom of our structure? The headroom of our structure, I need to look at the architectural file. The architect specified a headroom of 3,000. That height is the distance between the top of slab to top of slab. That is what is called headroom. Okay? So this 3,000 is what should be reflected here. I don't know for this other file that I shared with you, this is now 3.1. So even in your design, I would expect you to have 3.1 here, 3.1 like that. So the headroom here, the height h, is this distance which you get from the section, from this cross section. Floor to floor height. Yeah. So here is 3,000 all through. I'll just keep it like that. Then one other important setting here is this. Assume roof has normal story. If the roof has, if the project is going to be roofed with just a normal slab, then you're going to mark this option, assume roof as normal story. But then if your project has parts which are having maybe a hipped roof or trusses or something like that, then you are going to leave this one blank. So this is the kind of project that we have. If I look at this project, most especially the elevations, let me go to, it has some hidden, it shows as if there are slabs, but inside there are trusses for hidden roofs. So we need not mark that option. I'll click OK. Flat roofs on. Yes. Okay. So you need to keep on saving your work. Unlike AutoCAD, which has auto recovery or drawing recovery, Structure doesn't have recovery. So in case it crashes, you need to go back to 0 and do it again. So you can keep on pressing Ctrl S to save. Now, I'm going to leave you with a task. Let's draw beams. Let's draw beams, but we are going to be following this layout. I added a photo of, to do with setup layout in what I shared with you. This is how we are going to assign our supports. So for the beams, how to draw the beam, let's say connecting from this column up to this column. Under modeling, you click on beam. You click on beam. By the way, you should make sure that the view which you have has columns. So because you're connecting those beams to columns, don't launch the beam command when you are on first floor. There's no column there. Before you click on beam, make sure that in your layout you can see columns there. So and now columns are on plinth beam level or ground floor level. Yes. Okay. So we click on beam, select beam, you give it a member property. B is the width of the beam. We are going to use beams of 200 and a preliminary depth of, let's say, 400. You click on beam under modeling. You click on beam. You get this properties palette. You see where there is B and H. B represents the width of the beam, 200. And the depth of the beam is going to be, let's have 400. Okay. Then after that, you need to click where you want them to connect, like from this column. Ensure you have axis intersection, you click, and then also to axis intersection, you click. Clicking on the last column has left me in the command of drawing. You need to just right click. Then when I look at this layout, I have a secondary beam at this point. So when you are creating your beams, it is advisable you first create the primary beams onto which the secondary beams are going to be attached. To avoid misinterpretations of cantilevers in sections where they are not cantilevers. You get it? So first add a primary beam like from that axis intersection up to that point. You right click to stay in command. Then from this point up to that point, right click to stay in command. So my point here is when you're drawing beams, they should be at axis intersections where you have supports. But then it will take a lot of time for you to identify axis intersections. You can also just make a window selection like from this point. As long as you have enclosed the supports very well up to there, you click. Like I can draw from this point. Don't drag, just click That point, enclose the two supports, and then that point you click. So I'll draw also for this other side, let's say from that point up that point. Also here to there, then this is the intersection from there up to there. Okay. So from here up to here. Then from this point up this point. This is where we have the staircase. Can draw connecting the two, that point. Then also connect these ones, this point. I look at this. Okay. I connect from this point up to this point. Then also from this point up to that point. Also here, make like that. This. You're connecting all columns. No, there's a photo setup layout which I shared there. It's what I'm following. Arrange them. How do you remove the beam? You select it, you click on it, and delete. Press delete button. Yes. That's okay. I think it's adopting the layout which we conceptualized yesterday. Okay, at this point, we have a concealed beam. This beam which runs along grid F from here up to here, between the dining and then the sitting room. Yes, all those green concealed beams. No, they should be concealed beams. Yes, come to that. So the beams which run along grid F between 3 and 6 on grid F between grid 3 and 6, that beam is going to be a concealed beam. You double click on the beam that you have created along grid F. You double click on it to create a concealed beam. Then change the properties. What has been the depth becomes the width, and then the width becomes the depth, which is 200. Okay. Now on grid F, when you look at this layout, here, this is the sitting room and dining. We do not need like a drop beam, like something protruding out from the slab. So this is going to be a concealed beam. The concealed beam must maintain the cross-section area of the concrete. Okay, so what has been the width becomes the depth, and the depth becomes the width. But you know, that is the principle, but at times, depending on how your ribs are going to run, if it's going to be a rib slab, you might find that in some cases the concealed beam has a bigger cross-section area compared to the drop beam because it takes a lot of reinforcement. You get it? Yeah. Yeah. How to draw it? You flow like these ones, read axis intersection and this intersection, and then you double click on it. You change the width to 400, then the depth to 100. Then you update. How about? You ask me when you apply this. Now, when you look at this beam here, some parts are going past the support. So here you're going to apply the eccentricity. Remember when I was telling you that when you select the member and you press the arrow key on the keyboard, it shifts a given distance. So then you are shifting this beam to the left in order it matches the face of this column matches with the outside face of the beam. So when the rebar is going to be curtailed, it runs straight like this, and then once it comes here, it can receive like it can be anchored within this one. Yes, please. When you have drawn one stop element, the inflator is going to pull up the mark to the second one. Yes, there will be that. Yes. format M8. M8. This one should have been at M9. So yesterday where did we put it? Yesterday we had country. It's going to be a long process to change that. It's just this. Let's keep it. Let's keep it the way it is. So you should avoid making random movements when you are designing. This business of just clicking on the element and then you press the arrow key on the keyboard, shift the position. You need to be accurate. You need to know the exact distance which you are moving. So you can right click and then get the measure tool. You measure like from this point up to this point, how much do I need to move? -50. Okay. Then you can double click on that element and then use this E1, this E here, E and then EZ. Okay. Just enter the distances there. Oh, to identify a facility is pretty to have a wider. No, you need to know as the structural engineer, either you need a concealed beam here or not. But then how you determine is the function of space of the concealed beam, that beam, you know, a slab beam. So that beam which doesn't project from the slab down, so That's the question. If in case that the space maybe is a conference room, they don't want these drops from above, like the ceiling or in the slab, then you need to seal the film. It is you to determine, but then you need guidance from the structural. Yes. Yes. Yeah, there could be an arch, but then below that arch, there's going to be some muscle below it. So that masonry can be hidden the block. So there you can put a block in. Yeah. Okay.
So at the time when we cleared it, it's supposed to have written the project. So
Yeah. Okay. So in our next meeting, I would expect you to come back when you have that layout already drawn. Okay. Once you have the first layout, the other layouts become very easy. It will be just a matter of replicating what you have already drawn.